Today, I want you to imagine we're following a smart explorer on a quest. They're searching for treasure, but in a totally unknown land. It's a journey that's going to show us how AI is making this incredible leap from just making short-sighted guesses to developing some seriously powerful long-term strategies. All right, let's just dive right in. The question here is, well, it's a huge one in AI. When you can't see the whole map, how in the world do you find the highest peak? And maybe more importantly, how do you make smart choices when every single guess you make is really, really expensive? And that gets us right to the heart of the problem, something called black box optimization. Picture this. You've got a mysterious box. You have no idea what's inside, no clue about the formulas or the gears turning. All you can do is put something in and see what comes out. The only catch? Every single time you test it, it costs you. It costs you time, it costs you money, or it costs you a ton of computing power. And look, this isn't just some abstract theoretical thing. We are talking about massive, real-world challenges. Things like tuning a giant AI model that powers the apps you use every day, or searching for the exact molecular structure of a new drug that could save lives, or even designing a revolutionary new material for better batteries. Each attempt, every single data point, can be ridiculously expensive. Okay, so you get the picture, right? We need a strategy. We can't just guess randomly. That would cost a fortune. The goal here is to be incredibly efficient, to find that one perfect solution, that highest peak on our hidden map, using the absolute minimum number of attempts possible. And this is where something called Bayesian Optimization, or BO for short, comes into play. Just think of it as our AI-powered smart explorer. It doesn't just wander around hoping to get lucky. Nope. After every single step, it stops, it takes a look around, and it updates its mental map of the terrain. And then it uses that new, better map to make a super educated guess about where to go next. So the basic strategy is actually a pretty simple loop. First, it builds this probabilistic map, it's called a surrogate model, that shows where it thinks the good spots are, the bad spots are, and, this is key, how uncertain it is about different areas. Second, it uses what's called an acquisition function, which is basically its decision-making rulebook, to decide what to do. Should it exploit a known good area, or should it explore some mysterious, uncertain region? Third, it takes that step, gets a new piece of information, and updates its map. And then, it just does it all over again. But here's the catch. This basic explorer has a really critical flaw. As Zhang and his colleagues pointed out, these strategies are often myopic. They're short-sighted. They only think about the single best move they can make right now, not how that move will set them up for better moves down the line. It's kind of like a chess player who only thinks one move ahead. Not going to win many games that way. Oh, this slide just nails the problem. Take a look at the graphs on the left. That's our myopic explorer. It finds a pretty good peak, a local optimum, and then it just gets stuck there because moving anywhere else looks worse in the short term. It totally misses the real prize, the highest peak, which is hidden over in that uncertain area. Now, look at the explorer on the right. This one isn't myopic, it's smarter. It takes a calculated risk to check out that unknown region and boom, it finds the much, much better solution. So right, that's the big challenge. How do we upgrade our explorer from a simple, short-sighted strategist into like a grand master who can actually think multiple steps into the future? And the answer, which is pretty wild, is to teach it how to daydream. We literally give it the power to fantasize about what might happen if it takes a certain step. So here's how this whole fantasizing thing actually works. The AI asks itself, okay, what if I go test this spot over here? Then, using its map, it imagines, or fantasizes, a whole bunch of possible outcomes for that test. And for each of those imagined futures, it then plans what its next best move would be from there. You do this over and over, and you start to build out this massive tree of possible future scenarios. But as you can probably guess, this creates an absolute computational nightmare. I mean, this tree of possibilities just explodes in size. Thinking 2 steps ahead is tough. 3 steps is way harder. And trying to plan 4 or 5 steps into the future becomes, well, practically impossible. It is just way, way too slow. And that is where this really clever trick called one-shot optimization comes in. Instead of trying to solve this crazy nested puzzle one step at a time, it basically lays out the entire decision tree and finds the best path through all of those fantasized futures, all at once. It's a massive shortcut that suddenly makes planning several steps ahead totally possible. Okay, so our explorer can now think ahead. That's a huge leap. But a truly intelligent explorer needs more than just foresight. It also needs to be efficient. It can't waste time and energy fantasizing about every single unlikely path. It has to know which possibilities are worth thinking deeply about and which ones it can just ignore. And it turns out, researchers have come up with two main ways to do this. On one hand, you can just simplify the planning process. So instead of building out that full, bushy tree of futures, you just follow one or two of the paths that look the most promising. On the other hand, you can focus on making your fantasized maps better and clearer, so your decisions are based on much more reliable info. And this image is the perfect way to see what I mean. On the left, you've got this noisy, chaotic map of the future from a standard simulation. It's hard to make a good call based on that, right? But on the right, by using a statistical trick called common random numbers, the map of the future becomes so much smoother, so much clearer, and that gives the explorer the confidence it needs to make a much better long-term choice. Okay, now we're getting to the really cutting-edge stuff. We've given our explorer foresight and efficiency, but what if we could give it the whole toolkit? I'm talking a super detailed local map for what's right in front of it, a global heat map to show it promising continents to explore, and a brain that actually learns how to best use both. This is where this fascinating tool called an energy-based model, or EBM, comes into the picture. Think of an EBM like this. It creates a global, an energy landscape. It learns to assign low energy, think of that as fertile, easy-to-walk-on ground, to the most promising parts of the entire search space, and it assigns high energy to all the barren, unpromising areas. It's basically our global heat map. And when you combine all of these incredible ideas together, researchers have created what might just be the ultimate explorer yet. They call it REBMBO, the Reinforced Energy-Based Model for Bayesian Optimization. So let's break down the ultimate explorer's toolkit. It uses the Gaussian process for that super reliable, detailed local map we started with. It uses the energy-based model for a global heat map, which keeps it from getting stuck in some small local valley. And finally, it uses reinforcement learning as its adaptive brain, learning from experience when it should trust the local map and when it should take a leap of faith based on the global one. And this is the real game changer. That reinforcement learning part lets the explorer adapt its look-ahead strategy completely on the fly. If it's in a simple, smooth landscape, it might just act myopically, because that's efficient. But if it's in a really complex, tricky landscape with tons of peaks and valleys, it learns to think more steps ahead, dynamically changing its entire approach based on what it's seeing. And this leaves us with a pretty fascinating thought to end on. We've gone from a simple, short-sighted guesser to a fully adaptive, long-term strategist that can navigate these huge, expensive, unknown spaces with incredible efficiency. So the question isn't just about finding the best answer anymore. It's about what problems we once thought were too complex or too expensive to even try, are now finally within our reach.